All right, what do we have here now? Another Venn diagram example. Nothing too interesting about this one. It's the set is already laid out for us. We've got our universal set is everything in the box. We have a set A overlapping with the set B. We have numbers all over the place here. Well, this first one, write down the numbers that are in the set A. Now over here to the side here, I wrote down what these symbols are. That stands for, it means intersection, meaning what are the values that are only in both sets? Well, I'm looking up here and I see that, oh, let's do, where's my fill box here? Because this is fun to do. Let's go with the orange. Yeah, only, see, that's where they overlap, only in both there. So back to here, and we're going to write down, write down your, don't forget your brackets, 4 and 9, only in both. Now the U here stands for union. That means in both all together. So we want to know all the values that are in A. Let's add another color here. Blue, fill, here, here, and here. All together in A and B. So got my pencil, black. No, that's my typewriter. Equals to. This is so much fun. 16, 25, 36, 4, 9, 5, and that looks like it. Double check, that's it. And then the complement of A. Okay, what we're going to do now is complement of A is what's not in A. So this is why I'm going to here what we'll do is we'll block out A. Okay, all these values are in A. Gray we're blocking out. Green, that's everything that's not in A. So that's what we want is the green values. And down here equals to just the ones that are green. So we'll go with 17, 5, and 40. All right, now we've got one of the numbers in the diagram is chosen at randomly. So I'm going to reach out here and randomly grab one of those numbers. Well, I think I need my pencil here. And right, don't forget your P of something is equal to the total number of options. And I would say what you want, but it's the number that you have available, right? So here we have, let's do the total first. Now, in this case, I need the total number of elements. So I need to count these. I've got 1, 2, 3, 4, 5, 6, 7, 8. So on the bottom, we have the total number of elements is 8. Okay, now we're looking for, find the probability that the number is in set B prime. I always say prime, but what we mean is the complement. So we've got to figure out what that is first. Let's do. Okay, we're going to do the same thing again. I need to block out B. That's, there's B, right? And what's not in B is we're going to highlight in green. And now I'm going to count those. Let's just smudge this up a little bit. Yeah, why not? Brush. So we we want the ones that are in green. So 1, 2, 3, 4, 5. Nice. Change this over here. So 5. Well, that's our probability of, if we randomly choose a number, that's going to be one that's in the complement of B. Now, we could leave it as 5/8. The probability is 5 out of 8. I could change that to a decimal, and I think I'll do this one in my head. 4/8 is a half. 1/8 is half of a quarter, so that's 0.125. So I'm going to say 0.625. And remember, this has to be less than or equal to 1 and greater than or equal to 0. So we're happy with that answer. I can also write that as a percent. Just move the decimal over 2 places. That's 62, but I have to remember to add that percent sign. 62.5% chance that if I grab one at random, it's going to be one of the green values, one of the complements of B. That was fun. Hope you enjoyed it. Have a good day.